So to recap, what we were talking about is how you can import libraries in order to get good stuff, such as math functions. Let's see what, if I just type in important Python libraries, see if somebody has a, well, no, all righty, Mr. Sharkey here doesn't seem to want to work for us. Take another look. All right, so creating a module. To create a module, just save the code you want with the file extension py. All righty, great. Define greetings. Okay, this is not exactly how I would want to do it. And I'll show you what I mean. We're actually going to be going a little off field here, but I think that's kind of okay. All right, so if I make a new file and I put they called it a module, they're calling a module a py file with a function in it. I guess that's a good enough definition. So I'm going to define a function that's called hello. So def space hello parentheses colon, and all it's going to do is say print hi. And then I'm going to save that. And I'm going to call it, I don't know, just a silly name, P1. Something easy to remember. And then I'm going to create another file. And this one's going to say import hello because I want to call it, excuse me, it was called P1, wasn't it? So import the P1 module and then call P1.hello. So I'm going to save this one as P2. So P2 is going to import P1 and then call one of the functions in it. At least that's the goal. All right. And that actually worked. So that is a good way to do it. If we did not have our code in a function, or if we wrote an entire program over here, right? We have one that says hello, and we have one that says goodbye. And then we print, bye when we call this function. And then I'm going to call those, right? Hello, goodbye, like that. That's normally how you write a program. You define your functions up at the top and you declare your, you call the functions down at the bottom. Very typical. Oh, maybe if I spelled goodbye correctly, it would work better. Let's remove one of those O's. All right, that works great. So now I'm going to come over to P2. And without even having, say I just want to make sure that P1 exists, I'm not going to even add any code here. So I'm going to import P1 and I'm going to run it. And just by the sheer act of importing it, it ran all the unindented code. And you may not want that, right? There's a way that you can put your main code. This is the main code down here, right? This is the main code that uses the functions. You can put your main code in its own function so that it doesn't get called when you import it. Because otherwise, just the mere act of importing it, it'd be real drag if I imported math and the math module started printing some stuff on the screen. So here's what we might do. We might actually define ourselves a main function, def main, parentheses in parentheses colon. And then when I run it, great, it doesn't do anything. But at least when I go over to P2, and give it a shot. When it imports it, it doesn't do all that stuff. All right, well, now it's not running at all. All right, that's not an improvement. Nothing does anything. Well, over in P2, we could call the main module when we're ready, right? We could call main if we wanted it to run the whole thing. Oh, I'm sorry. It's called p1.main, is it not? Because we import the p1 module to run it, we would have to call p1.main. And it did, right? So we imported it, and then we called the main module. What if we also want to be able to run it over here, right? What if we actually wanted to be able to run P1 on this side and have it do something? It's not. Well, you can invoke the main module, the main function, by writing a little bit of special code down here. And to get this to work, we're going to be using double underscores. So when I say double underscores, I mean hold the shift key and type the minus, so that you get 2 double underscores in a row. And we're going to use a lot of them in this next statement. That's why I'm kind of hammering that in. We're going to write some code that says if underscore underscore, 2 of them, name underscore underscore equals equals, quote, quote, and inside those quotes, I'm going to put some more underscores. Well, come on, I said right there. Underscore underscore main underscore underscore colon, and then on the next line, call main. Now this looks weird. This is using some hidden variable that gets initialized when the program is run. And only one PY file during the running of the code gets the name of itself to be called main, and it's the one that you actually run. So if I click run over here, I mean, heck, we could actually print out the name of it if we wanted to, right? We could say print out underscore underscore name underscore underscore like that, just to see what it says. And then I'm going to go over to P2 and comment this call out to main, just to prove that everything is still perfectly set up so that it does not automatically run code. Although this is unindented and it is going to run that, but we're going to delete that. We don't want that there in our final copy. So let's test it first to make sure that it does what it's supposed to do on the P1 side. And it does, right? It got down here. Name was equal to main, and we can see that because when we printed it out main. So we know that when we run this program, this secret variable name is equal to main. But if I come over to P2, I'm going to do something, print inside P2 name underscore underscore name underscore underscore equals comma underscore underscore name, right? And I'm going to make this one say the same thing. This is inside P1. Let's make sure I haven't broken the code. So I'm going to run P1. And when we run P1, it says inside P1 underscore underscore name equals underscore underscore main. And that's why this if statement works. If I go over to P2 and run it, let's take this out temporarily. Inside P2, underscore underscore name is equal to underscore underscore main. That kind of makes sense. We are running a program and it has to pick a main PY file. And now that we're running it inside P2, P2 is the main file. But what happens when we add our import? Temporarily, I'm going to put it below this one, just because I want to see the messages print in a certain order. All right, so now when I save it and run it, inside P2, which is the one that I ran, right, the one on the right, name is equal to main, but inside P1, which got ran when I imported it. When I imported it, ran all the unindented code, and so it ran that one. In that case, that secret variable inside this module equals something other than underscore underscore main. So we have locked the call to the main method inside an if statement that is only true when we run that code from that file. If we run this code from a different file by importing it, then in this context, this secret variable is not equal to main, and so it does not run the main function. I don't know if that makes sense or not, but if I was going to teach you right, I should probably put all of my code, whenever I give you a demonstration, inside a main module, and I should stick this down at the bottom to get you in the habit of doing that, so that if you ever write a bunch of cool functions that you want to import into another file, into another program, then you can do so without it triggering all that stuff. I mean, imagine, like last Monday's or Wednesday's code when we have, 300 lines of code. And then I tried to import lecture C into lecture D in order to get a function out of it. It would run those 300 lines of code, but not if I had defined those 300 lines of code, minus the length of the modules, the functions, and cordoned them off like that. I could have just done the same thing by doing this, right? Not even make a main, just put all of the good stuff down here inside this if statement. And it would work the same way. If I go back to P2, oh, by the way, you don't see me do it, but as soon as I make a change to the program, it puts an asterisk here. And then every time I toggle to the other code file, I hit Control S to save it, to get the asterisk to go away, because it doesn't save it automatically. It only saves automatically the one that you're trying to run, right? So if I go over here to P2 and I make a change, yeah, sure, that one's got an asterisk. P1's got an asterisk, but when I run P2, come on, come back P2. The only one that gets asked to be saved is P2. Let's make apparently I can mute myself. I did not realize I had hit a key to mute myself. All righty. So when I ran P2, it asked me if I wanted to save it. And I did, but it never asked me if I wanted to save P1. So pretty much as soon as I make a change, I just hit Control S. It's just habit. And so hope that makes sense. Now, where was I? Okay, over here, I can still run the code from P1 and it works beautifully. It says hi and bye. Switch over to P2. I'm going to take this statement out. We don't really care about where we are anymore. I guess I could just comment it out. Control S to save that one. Comment this out. Control S to save that one. Come back over to P2. Now when I run it, the import statement is not going to do anything except bring the functions in. And that's what I want. And now I can use it, right? Now I could call, hello, 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 and it's going to print out hi each time. However, since I imported it as P1 and the functions are in the P1 module, I have to prefix them like this. All right, cool. And by all rights, I should put this syntax over here too. I should go to P2 and do this, indent this stuff under P1 like that. I mean, indent this under the if statement. And now it's going to work okay too, but if I ever imported P2 into anything, it wouldn't automatically run. All right, so it's working the same way. Now we saw in the PowerPoints the alternate syntax for importing, which is to do this. From P1, you can import a specific function. Like I might want to bring in the goodbye function only. And if I use that syntax, then I don't have to prefix it with P1. I could just call goodbye like that, right? Without calling it that. Now, I think a slide in the PowerPoint is going to show us this. You can name the function as you bring it in. So I don't have to call it goodbye. I could call it whatever. Right? Like that. And that worked. So you could do the as keyword. You could say, please import this function, but rename it that. Now I never do that. If you want to bring in all the functions from a file and not have to prefix them with the name of the module, you could just import them all, right? From P1 import asterisk. That'll bring them all in. All right. I'm not really having expected you to type all that stuff in. So I think I'm going to switch to another file called lecture D. I'm going to get rid of that. Right? That was a little bit too weird. Why don't we just go back to calling it goodbye? All right, now it's still running good. Okay, so I'm just going to close those. We're going to start fresh. Create a new file, save it as lecture D. All right. Create a doc string. This is file lecture D, which finishes chapter 2, begins chapter 3. And what is today's date? I believe it's the 11th. That's the 10th. All righty. Modified June 10th, 2020. All right, there. Kind of trying to make it look professional. I am going to skip, unfortunately, putting everything in a main module. I might start doing that later, but it's just extra typing, and it's easier to say, all right, this should all be unindented, rather than saying, okay, this should all be unindented except for one tab level, right? So not going to do the main business, but I'm going to make comment of it. I should put my main code in a method called, I'm sorry, that's a function. There's something called a method, which is a function that's attached to a class, but we're not talking about classes, so I'm going to keep using the word function. And a function called main, and then call main inside an if statement that looks like this. I think I'll take out the word that looks. All right, and what was the syntax? It was if underscore underscore name underscore underscore equals equals quote underscore underscore main underscore underscore end quote colon then call main, right? For simplicity's sake, I won't do that in this day's example. Although I will upload the other files, P1 and P2 as well. So a function is a chunk of code that can be called by its name. Going to write a function. Function is a block of code statements with a name. I think my definition is better than theirs. So I'm going to write a function called add2 def add 2 that takes an x and a y parameter, and it says result equals x plus y, and then it returns the result. You invoke, call the function by using its name and passing in arguments to fill the parameter variables. So let's add a comment here. X and Y are parameter variables, which you can just shorten and say parameters, of two numbers to add. Function returns their sum. All right, so there's my doc string for that. I added a doc string for the module itself, the whole program, and I added one for the function to describe what it is. So if I come and look at it later, and also, now this isn't going to actually do anything because I never called it. I only defined it. When you run a program, it doesn't automatically run the code that's indented, but it's waiting in memory to be called. I can type in parentheses help add to, and it'll tell me, okay, this is how you run it. I could have even put an example here, right? Example result equals add to 10, 20, right? So I'm going to run this just to reload that function. And then when I do help add to, it tells me what it is. And so I'm going to try it out. Result equals add to 10, 20. And then I'm going to just type in result, and I find out that it's 30. Looking good. All right, so why don't we call it out? R equals add to, 10, 20. Print, quote, the add to function returned, end quote, comma, R, right? $10 and $20 are the arguments. They fill in the parameter variables X and Y. All right, so we've talked about the help function. Just as a reminder, the round function has an optional argument, optional parameter that you can use to customize its behavior. If I say X is equal to 1.23456, and then I say A is equal to round X, it's going to be 1. Just print A equals, comma 1. But I can say B is equal to round X, comma 2. And then when I print B equals, end quote, comma, wait, I was supposed to be trying to print out the value of A, not 1. I don't know where that came from, right? So A equals A and B equals B, right? Like that. And so since I said round X, comma 2, it rounded it to 2 places. Since I said round X, it rounded it to an integer. Round has an optional parameter. You can call it without it, and it just returns the whole number. Example, A equals round B. B will be rounded to a whole number. Let's add another example. A equals round B comma 2. B will be rounded to 2 places after the decimal, which they call the precision. We could do that, sound technical. There we go. All righty. So functions and other resources are coded in components called modules. The module is just a PY file. There's a math module you can import. You get things like square root and pi. It turned out that I thought that ABS and another one were defaulted, were in math.pi, but they're included in the language by default instead. So the main module, you can call the main module. Yeah. I don't know how you call it the main module, but the main module is the code with either your unindented code or your code inside the main function. So program format and structure. Start with a comment that includes the author's name, the purpose of the program, and other relative information. Then include statements that import the modules that you need, that initialize important variables, suitably commented, prompt the user for data, process the input to display the results, and then display the results. So different ways of running a Python script. You can just load it into idle and then run it. And in this class, that's normally how you're going to do it. Or you can create a Python script inside a command prompt or inside a terminal window on your Linux or your Mac. So I'm going to create a file called test.py using the terminal window on a Mac. And on Windows, instead of using Nano, like I'm going to be using here, you just type in Notepad. Let me see where do you change the size of the font? Why don't they make this difficult to find? I just want a nice size font. It didn't change it. Maybe if I create a new window. All right. So Nano or Notepad on Windows, t.py. Here it is. I'm going to just, this is a kind of annoying editor, but it comes built in by default in all Linux and all Mac installs. So it's just going to print, hi, I'm Python. All it's going to do. Now I'm going to save the text. I'm going to exit it. Using Notepad so much easier. All righty. Now I'm going to actually run the program. The file is there waiting for me to run. ls is about the same thing as dir in DOS. And so I'm going to type in Python space t.py and it should run the program. Hi, I'm Python. If I type in Python without giving it an argument is a is a series of characters after the program name, then it'll come up and it'll tell me. Now notice that it's telling me that my Mac is running Python 2.7. I installed Python 3. but apparently it did not overwrite Python 2. It left Python 2 hanging here, and I haven't Googled out how to replace Python 2 with Python 3 so that it'll run Python 3 from the terminal. And honestly, I don't want to, because if the operating system is depending upon being Python 2, I don't want to break it. I feel like I should, though, but I'm not going to do it because in this class, I don't actually run my programs from the terminal window. If you do it in the command prompt under Windows, let's try that out. So I'm going to launch Windows 10. Whistle while we work. Sorry, when I rebooted it, it decided to reset the Windows 10 app, which seems to take a long time to launch. But that's all right, because when you reboot your PC, it takes a long time to launch Windows too. So I guess that's not too weird. All right, so here's my Windows desktop. I'm going to launch the command prompt by clicking on the magnifying glass and typing in CMD. There's my command prompt with itty bitty letters. Let's change the properties. It can be 24. I'm going to create a file, notepad t.py. Cannot find the t.py file. Do I want to create it? I sure do. Print. Look, ma. Output. Now, I think I just saved it in a really stupid place. No, I didn't. Never mind, never mind, never mind. I put it where I wanted it to. So I'm going to close this. If I do dir space t.py, I see my file there waiting for me to run, except it said 0 bytes. That's pretty weird. Where'd it go? I made some kind of mistake. All right, so dir t.py. It's 13 bytes now. All right, and so I'm going to run it. I'm going to type in python t.py. And it didn't do anything. If I just type in Python, it launches the Python store. I mean the Microsoft store. I shouldn't have to do that. Python is in fact installed on my machine, which I can find out by running idle. That means that Python is not in the search path. What is the search path? If I type in path on the command prompt, it lists a whole bunch of directories. Well, it is too. I see it right there. I'm slightly confused. I'm not going to spend much longer working on this problem. I'm going to go into the directory and make sure that there is something called python.exe. There is, but there must be another version of Python installed in an earlier version of the path, because I should just be able to type in Python and have it run that rather than trying to install it. Now, I guess I could just go ahead and let the Microsoft Store install it, and it would probably set up everything great. And maybe from now on, I'll have Windows users do that. I don't know if it's because I'm running it on Windows on a Mac or why it's not working correctly. If I go back into programs and back into Python and then cd back into Python 38-22, excuse me, 32. And then I run Python, it actually goes into it. So I don't know where Windows is finding the version of Python that it thinks it needs to download from the App Store. I'm sure that there are ways to figure that out. Not going to bother. All righty. So that kind of went awry. I'm going to leave that alone. But you get the idea that you can run it from the command prompt. If you run Python itself from the command prompt rather than the file, then it brings you up into the shell, just like idle can have a Python shell. I forget how you exit out of it. Exit with parentheses. All right. If you want to run it from the user interface, then you should just be able to click on the file name. There's the file name. Sorry for the tiny print. If I double click on it, it loads it up into idle. If you don't want it to load up into idle, which you do really, right? When you edit a Python program, you'd like to be able to edit it, but it could be that you'd rather have it run it automatically like any other program, right? You can change the way that behaves in Windows. You can right click on a file and say open with, and it'll list a whole bunch of things. Go away. PyCharm, no. Python Launcher, no, because those are the Mac versions. Again, this is looking a little bit weird. But if Python is not listed under open with, you can go choose another app. And then you can go and actually find Python under more apps. Why is there no browse version? Look for another app on this PC. Okay, and then I could go and actually find it, wander my way down to the directory, choose python.exe, click open, and it'll run it that way. Unfortunately, it runs it and closes it, right? You see that? I mean, of course you didn't. It ran it in a split second. So when I double clicked it, well, phooey. When I double clicked it, it launched it in idle. So I'm going to have to do it again. Open with, at least it's listed there now. But I should be able to make it so that it'll run it all PY files using that. So you choose another app. I want everything to be open with Python. Always use this app to open PY files. Now I'm going to regret doing that, so I'll have to fix it someday to edit these things in idle. So now when I double click on it, it actually runs the program rather than launching idle. But I didn't get to see what it did, so I'm going to edit it. I'm going to choose edit and see what it pops up. It's probably going to bring up Notepad. Yeah. So how do I get it to stay open so that I can see the results when running it from the Windows user interface? Mac user interface is probably the same. I'm going to just add an empty input statement to the bottom of my code that says input, done, press enter to close, right? Save it. Now when I double click it, it does its work. It prints hi, and then it says done. Press enter to close. And if I hit enter, it closes the window. All right. I think that's about enough about running Python itself. I ought to write up a document on it, but you can see, I should record a separate video that's only on that. Guess I could excerpt this one, do it again. Anyways, let's go back and look here. See, they're telling us to try to run it with the name Python 3. I'm not sure that's correct. If I type in Python 3, does it do anything? Well, it launches the Microsoft Store. That's using Windows. Let's try it under the Mac terminal. Exit out of it. Python 3. Oh, it did. What do you know? It ran the right version of Python. I like that. That's friendly. I'll remember that from now on. So if I wanted to run my program under Python 3, I can just type in Python 3 space t.py, and it'll run that Python program right there using the correct version. It's a real shame that Windows, even when I do it from the command prompt, and again, I'm not sure if this is a side effect of running Windows inside a Mac or not, but if I run it from the command prompt and I type in Python 3 followed by my file name, it doesn't run it. Instead, it wants to load it from the store. And I guess I'll do that in the background while we're lecturing. Unless it gets complicated and asking me passwords and stuff like that, I'm not going to waste our time figuring that out. How many times do I have to click get? All right, this is turning into, okay. Turning into waste my time zone. All right, just going to let it go. It's funny how this book assumes that you're running a Mac. Running it on a Mac and running it on Linux ought to be the same. So I guess they're covering 2 out of the 3. But, you know, we all know that, you know, 80% of the world, you know, or more is going to be running this stuff on Windows. I'm curious. So Python's installations allow you to launch Python scripts by double-clicking the file from the OS's file browser. But what we saw is that Windows launches idle instead, which is great. And I like editing my programs. But I would rather, if I was, you know, actually writing this to be solutions, you know, rather than being a student and running, you know, the editor, then I would need to change the default program. So it may require the PY file type to be set. There are more than one ways to do that in Windows, but doing that open with business by right-clicking on it and setting it to be the default program for PY scripts works. Unfortunately, Windows will close that window automatically when you launch it by double-clicking it, and so the solution is to add an empty input statement that pauses the program until the user hits enter, like this. Please press enter or return to quit the program. So summary. The waterfall model describes software development process. That was way up here at the beginning, right, where you get a request, you do your analysis, you do your design. If it turns out you should always validate each step, you know, go back to the customer and make sure that they understand, you know, that what it's going to do before you actually start coding it. Because a mistake, it's a lot cheaper to fix the mistake in the analysis stage than after you've already coded it and implemented and installed it on 1,000 computers. Then they find the mistake and you got to go all the way back to the, you know, to an early state, analyze it again, recode it and reinstall it. So customer request, analysis, design, always going back and checking to make sure that you've got the right design based on your analysis, and then that you have the right implementation based on the design, and then you test it, and then you can install it, which is the integration, and then you enter the maintenance cycle, where hopefully you've moved on to other projects, but as people find problems with it, then you go and you fix it. So literals are data types that appear in the program. In other words, they're the numbers and the strings that are literally typed directly into the code. What's that? No, I don't want to close that. That's a literal, right? That's a literal. It's typed directly into the code. The user would have to be able to edit the program in order to be able to change that. If I had a string, right? My good old, my name is Slim Shady, right? Slim Shady is a literal. You know, and my num is 3, right? 3 is a literal. It's literally typed in. I mean, that's not the textbook definition of why it's called literally typed into the code by the programmer. That's just my colloquial way of explaining it. To have that value changed, the user would need to have the source code edited. So a literal is different than user input, right? I could ask for the name, in which case I'd use an input statement. Or I could ask for the number, in which case I could use an input statement and convert it to, a number. Now, I'm not going to add input statements because we've already seen in the lecture that once you start adding input statements, you have to answer them every time you run the code. And, we're only in the first hour of it, so I'm not going to make us do that. But this is different than user input. Example, my name equals input, parentheses, what is your name? So why don't you make everything user input? Well, that's insane. You're not going to ask the user for the value of pi, right? Or for the density of iron or things like that. Things, that are going to be calculated that already exist in the real world, you're going to want to store in some other way than asking a user to type it in every time. So the string type represents text. Then there are numeric types. The ints are the whole numbers, and then they're the floats. An escape character begins with a backslash and represents a special character, such as a delete key. There are several of them. Where's my editor? There it is. Right. So escapes equals, hello backslash t. I'm not going to even put the spaces there. Hello backslash n. This backslash t is backslash t. And backslash t. Example backslash n of escapes, right? Escapes equals, they are a backslash followed by a character. Escapes equals example. You can use two of these to get a backslash to appear on the screen. New line or tab. So slash n is equal to a new line, slash t is a tab, slash quote is equal to a double quote, slash single quote is equal to a single quote. And that's so that you could do things like this, right? Print. Well, I guess I better end my comment. Print parentheses. I'm going to use a formatted print, so I'm going to stick an F in front of it. My name is, and in curly braces, my name for the placeholder. And so when it runs, it's going to print my name is Slim Shady, but maybe I want quotes around it. Right? My name is Slim Shady. I guess I never printed these escapes, so I never saw the results. So I'm going to add some print statements. Just type that in, copy and paste it several times. That. All righty, so this is an example of escapes, right? And everywhere I had a backslash n, it went to the new line. Slash n or slash t, new line or tab. And what if I wanted quotes here? Well, if I put quotes around it, all of a sudden it's broken. Because I started it off with a string character, string symbol, the double quotes. And so when it found another one, it thought it was the end. But I can turn it into an escape sequence by adding the backslash in front of it. Now, when I run it, it'll print it out properly. My name is Slim Shady, like that. You'd think I had a real thing for M&M. It's just an easy example. It's different than my name is Mud. All right, we're about done with the chapter. I'm not going to do the quiz for this one like I did on the other one. Comments are pieces of code that are ignored by the computer but can be read by the programmer. we know what they are. Variables are names that refer to values. Me being your super smart professor and modest too, I have a better definition. A variable is a named place in memory that contains a value, and it's got 3 attributes. A variable has 3 attributes, even spelled correctly. It's got a name. It's actually got 4. A type, such as string, int, or float, etc. How about that? And it's got a value, and then it's got a memory address. Now, in most languages like Python, you can't get a hold of the memory address. It's just completely managed by Python, which is a good thing, because if you can get a hold of a memory address and change it, then you could easily break the program, or you could try to edit, change values that the program doesn't even own, which is how, viruses and worms work, right? Because they manage to change memory in other parts of the operating system than the program is supposed to be is authorized to use. Well, anyway, so it has 4 attributes. We only care about the first 3. But if you want to use the textbook definition, it's fine as well, right? And if it asks in a quiz, thankfully it's multiple choice. So variables have names that refer to values, int and floats and strings, right? Those are all different kinds of data types. Arithmetic operators are used to form arithmetic expressions. For some reason, I always want to say arithmetic. I don't know why. It's just arithmetic. And the operators are ranked by precedence, where multiplication and division happen before addition and subtraction. And highest of all is star star, right? Mixed mode operations involve operands of different data types, meaning that if you try to add a string to a number, it's going to error because those are mixed data types. Now, if you add an int to a float, the Python handles that by converting the int to a float before the add is done. Since we're summarizing here, why don't we summarize, arithmetic operators? Arithmetic operators. I don't know why I'm not in green text. Star star, you know what that does? That's exponent. And then there's addition and subtraction, and also floor division and modulus. Why did I say addition and subtraction while I read that off? That's moronic. Multiply, divide, floor divide, right, which means round down, and modulus. And then lastly, addition and subtraction. And these are arranged, these are listed above in terms of operator precedence, priority. Meaning that if you have the phrase 2 plus 3 times 4, 3 times 4 happens before the plus. So the result is 3 times 4 is 12, plus another 2 is 14. And not 2 plus 3 is 5 times 4 is 20. So that's invalid. The answer would be 14. Type conversion functions can convert a value of one type to another. And we have one for each type, one of the three basic types. So int, right? Int x will convert x You have also float. Why did I type int and mean float? Ditto for floats. And then str. Ditto for string. Be done with that chapter. Nope, I thought we were. So a function call consists of a function's name and its arguments. The function definition has a def keyword. Python is a strongly typed language. Seems like that word is coming in out of the blue. If I could, yeah, that's coming in out of the blue. I would not say it's the most strongly typed language. A really strongly typed language means that once you create a variable of one type, you can't reassign it a value of another type. So if I did name equals Jeff, then I would not be able to turn around and say name equals 3. Let's look up strongly typed Python. Python is strongly but also dynamically typed. Dynamic means that they can change in the interim. I could say name is equal to Jeff and then turn around and say name is equal to 3. Strong typing means that the type of a value does not change in unexpected ways. Well, that's good to hear. A string containing only digits doesn't magically become a number, as may happen in Perl. Well, that makes me not want to use Perl. Every change of type requires an explicit conversion. Why don't we just make that our little note inside here? I'm just going to copy that. Python is strongly typed. Every change of type requires an explicit conversion. However, there are cases when Python will convert them on the fly. Python will go ahead and change an int to a float in order to do math when you add an int to a float. However, it will not automatically change a string to a float in order to add a string to a number. So if you wanted to do something like this, this would be an error. A is equal to 2 plus 3. Because the user typed in 3, 3 was input. That's an error. So A is equal to 2 plus int 3 is A-OK, right? A module is a set of resources, a set of functions. You just define a whole bunch of functions and stick them in a PY file, and you can import them into another one. A semantic error occurs when the computer cannot perform the request. So for example, say I do this, f is equal to open myfile.txt, end quote, comma, quote, W for writing. No, for reading. I want to open this file for reading. Well, there is no myfile.txt as far as I know. So when that runs, boom, it's going to crash. File not found error. That is a runtime error. And then they have the gall to say that that's a semantic error. I disagree, but I will run with it as far as this class is concerned because that's what this textbook does. In other textbooks, the semantic error is the logic error. And then if it cannot do the requested operation, that's called a runtime error. So why don't we list that as part of our notes? I'm going to delete that. A semantic error is a runtime error when a requested operation cannot be completed. That's opposed to a syntax error, which is a misspelling or typo or other mistake in the grammar of the language. Right, you use the input function, but you spell in with an M. That's a syntax error. You know, bad tabs, unclosed strings, right? You're missing a quote, mistyped variable names. The one that people tend to do the most often is to mix uppercase and lowercase, and sometimes, you know, they will say result equals 3 times 4 or 3 times 3 and then print result like that, right? Just because they're in the habit of whenever you sit at a keyboard, you capitalize the first thing in a sentence, right? So these are often upper lowercase mistakes because it is a case sensitive language. All righty, let's go look at the chapter quiz. No, not the chapter quiz. Let's go look at the sample code that they give us and then a programming problem or two. Okay, so down here in data files and code examples, Unit 2 data files, let's go take a look. Takes a while to open, of course. It finally saves a zip file that I can then open. See what's in here. Oh, and just one of them. That was the taxform.py, which is their example of a well-written program using constants, uppercase constants, and then asking for input, and then using good comments, and a doc string up at the top. Well, that didn't take long, especially since we've already done it. Let's go and look at the programming problems. So the chapter programming exercises, there's 4 for chapter 2. And interestingly, these are actually some kick butt hard programming problems. Not all of them. Like they start off doable and then they go off hard. So it's okay for you to ask for help when you're doing these. You know, if it turns out to be too challenging after you ask for help, I may even record a 5-minute lecture so that everybody can see how to do it. That's okay, because you learn from the example. You learn more if you can figure it out yourself, because some of the best learning occurs when you pound your head on the keyboard in frustration before you figure it out, right? But anyways, okay, so here's problem 2.1. The tax calculator program calculates a floating point number that might show more than 2 digits precision. Use the round function to modify it to display at most 2 digits of precision. Now, there's honestly more than one way to solve this, but since this is talking about the round function, I'm going to go ahead and use the round function. Here's what they want it to look like. Enter the gross income, type all that, the number of dependents 1, and then it's supposed to print out negative 130.87. Well, let's see if that's the case. The way the code works right now, before we fix it, we type in 1, 2, 3, 4, 5.67 with 1 dependent. And oh boy, that is not 2 digits. So we need to round our answer to 2 digits. Let's do that. So here I'm going to round it before displaying it. So I'm going to modify this to say income tax with a capital T equals round income tax with a capital T, comma 2, because I want to round it to 2 places. Now let's try it out again. So I'm going to run it a second time. 1, 2, 3, 4, 5, 6 dot, wait. 1, 2, 3, 4, 5.67. One dependent, and it's negative 130.87. That's what they want. Okay, so I got their example to work. Now I need to get credit for it. So I'm going to come over here and click on tasks. Run the checks. And I got full credit for it. Pat myself on the back. What if I got it wrong by typing in 3 there, or just by typing round with no second optional parameter? All right, correct solutions. I didn't get any of them. So 0%. If I click on the arrow, it tells me what I did wrong. They tested for 1, 2, 3, 4, 5, 6, 7 with 1 dependent, and they tested it for 9, 8, 7 with 2 dependents, and they tested it with 3, 1, 4, 1, 5, 9 with 3 dependents. And so here was their input, and here's what my program displayed as the result. What they wanted was to see 130.87. So I can see what I displayed, what they wanted. There's a question mark there. Green keywords were present in your program. Red keywords were missing or out of order. Anyways, this is the output that they wanted. That's what we gave them, so they counted it wrong. Alrighty, so that's the first problem. I should have submitted it when it was working correctly, right? So I'm going to change that back to round income tax, comma 2, run the checks again. I got 100%, so I'm going to click the green button, submit 100%. Alrighty, now I want to go to the next problem. Sure would be nice if I could get to the next problem without exiting out of this, and I don't see a way to get to the next button, but it's not a bad idea just to go back here and to run them from Canvas, because sometimes I skip problems. And as the chapters go, I skip more and more problems. Quite often I base some of my homework based on the idea of the programming problem, but it's hard enough that I want to write it up myself. Anyways, next, get to 2.2. I'm certainly not going to do all these. I'm just kind of making sure that you know how the code environment works. Taking a while. Write a program that takes the length of an edge as an input and prints the cube surface area as output. And they want it to work like this. Enter the cube's edge for the surface area is 96 square units. You know how to do input and output. You know how to Google up how to get the surface area of a cube. If you get stuck, I'll give you the formula, right? But we could write a program that's going to use an input statement. It's going to perform a calculation, and it's going to print the result. Now, honestly, when I'm writing it, I copy and paste these things because I don't want it to complain that the output's not exact, right? So I would do something like edge is equal.
Get that.
Was not
Could you try
talking
again?
All right. Like that, edge is equal to, and then I would put the question in directly there, right? Even with the space to match that. And then if I want the result to be correct, I'm going to get the answer wrong. I'm just going to set the answer to 0. I'm going to try to use the formatted print statement to see if it works in this compiler in MindTap. I'm not sure it's going to. But anyways, I'm going to print the result. The surface area is, except we better not just put 96 there. Might work for one of the tests, but it's not going to work for them all, right? And so I'm going to put the placeholders there. and I'm going to put the name of the variable inside the placeholders, and I'm going to put an F in front of the quote, and I'm going to hope that MindTap accepts that, right? So I'm going to type in something 4, and the surface area is 0, right? So all I would have to do is put the correct equation there, and it would be good. That's using a formatted print statement. Trying to make this larger so that you can easily read it. Well, here's how you do it without a formatted print statement. The surface area is, end quote. I don't even need that space there. End quote, comma, area, comma, quote, square units, period, end quote, right? That should work as well. It should produce the same result. Right. So identical output either way. You can do your output using formatted print statements, which is my favorite, or by using print statements where everything is separated by commas. Your choice. All right, going back to here, maybe click next, look at the next programming problem. I did give you all a bunch. I don't feel too guilty about it. Maybe check number 4. Write a program that takes the radius of a sphere and prints out the diameter, circumference, surface area, and volume. We can do all that. We know how to do all that. They're going to want to use pi. You might be able to get away with using 3.14159, but I would import math and use math.pi, right? So I'm just going to write and do one of the conversions, not all of them. So we're going to ask for the radius. It's weird that they don't make it look like an input statement, but we'll do it. R is equal.
Get that. Could you try again?
I need to that. I wish I could give Siri a harder name to say, like Alexa. All righty. So anyways, back to where we were. R is equal to, I'm not going to use int because we might want to type in a floating point number. So float, parentheses, input, parentheses, quote, radius, equals, space, like that. We're going to get the input, and then we're going to get one of the calculations. How about this one? 4 times pi times radius area. So area is equal to 4 times, I need pi, and I'm not going to use that special symbol, times radius to the power of 2, or radius times radius, right? But we're going to have to import math to get that to work. So from math, import pi. I've calculated the area, and I'm going to print the results. So print parentheses quote, no, print parentheses F quote, quote. I just copied and pasted it to get the spelling exactly right. Surface area colon. And then I need to fill in the number with a placeholder. So before the closing quote, area end quote, like that. So that would solve one of them. I need to solve the others. I'm not going to do them all. I could test it, make sure I don't have any syntax errors though. So the radius is 5. And boom, I got an error. So I'm glad I tested it. Radius is not defined. Well, I guess I should have used a better variable name than r. How about calling it radius, the whole word? Because that's what I used here. That was a syntax error. All right. There we go. Hopefully that's right. Looks that way. Okay. So go ahead and do those problems. They are worth credit. If you get stuck, let me know. If they look too hard for everybody, I'll record a lecture, mini lecture just over that one problem. All right, so we are going to stop here. Shorter lecture than normal, but I think that's okay. So your homework is going to be to do those problems and then to just upload a pic of the results, right? Just to show that you did them. All righty, gang. So I will see y'all next week.